So, the goal today is to finish this ANOVA and start with our regression. So we only have 3 classes left. The last week we will do a review and then exam, right? So this is the second last Friday class, okay? 2 weeks later, we're done already. So you should be glad that probably this is the last class of statistics in your life, unless you go to master level. I mean, probably this is the very last thing you will see. But I guess what we are teaching is going to be highly useful if we ever have to handle data. Okay. So let me review a little bit about what is analysis of variance, which we call ANOVA. That is a generalization of a 2-sample t-test of equivariance to the case of you have many groups. You want to see the mean of each group are same or not. In the other words, you want to know whether groupings would affect their mean or the group mean are the same or not. Okay, so this one way ANOVA. An application involves you have a data, you would be separated by gender or by cities or by age group, right, in a marketing application. So you want to see different segment of market are same or not. Do you need a uniform marketing strategy, or you need to segment the market, catering one with different marketing strategy? Okay. So the raw data would be a pair of information. The first information will be a numerical variable X, and the second information will be categorical variable. And by categorical variable means that the category doesn't mean anything. It's just different group. And later today, when we talk about the regression, actually we will, instead of the unmeaningful grouping, the grouping will be a meaningful one. So that will be the idea of regression. So the data will be, you can see listed in this way, right? For each row is an observation. So X1 represent the observation 1 numerical value, like wants to pay, how much they spend on the product. G1 may be locational variable, whether they're in Hong Kong, Shenzhen, or Shanghai, or their age group, young, old, male, female, or whatever you think that you have data with them. Okay. So the next one is the one that actually we use to denote our data, right? Will be denoted by 2 subscript, I and J. I is being which group they're in. If we have C groups, then you will be 1, 2, 3 up to C. And the second subscript represents the index of observations, right? So for each group, I will be Ni. So that's why we'll from 1 to N1. So the total will be N. Okay. So you'll be able to see this matrix form will be the one that looking at, right? G1 will be this group 1 will be X11 up to X12 up to X1N1, right? Same for that, and need not N1 equal to N2. Okay, so that would be the ideal group data. Okay, and as we said, this is going to generalize the 2-sample t-test with equivariance. So as in t-test, we will assume bell curve normal distribution. So here we also keep the same assumption because we just generalize from 2 group to more than group. So usually, same as before, we represent it as Xij follow a normal distribution with mu I and sigma square. Okay. So the key here to do F test is you have to assume each group have the same variance and they follow normal. So here is something very important because if we identify through the variance, if the variance are not the same, then this method fails. Okay. And you ask, what if this method fails? Then you have to use a t-test to do it. Okay. Because you know t-test of unequal variance. Or in the next semester, if you ever take the second course of statistics, which most of you will not, but if you ever going to do it, is 2021 that talk about regression, which extend what we talked about in the next class. So today we talk regression, but we talk about the simple version of regression. If you allow yourself to talk about a more general regression, then you can take into those account. Okay, but that would not be the scope of this class. So you can do it in the next course if you ever take. So this is the model. Okay, you will see the key is to check each mu are the same or not. Okay, and why is important? Because mu is the parameter, right? The mean we want to see. Okay, just to remind you that the notation, if you write the model, you can write the grand mean, the overall mean. It's average among all the group divided the number of group, and the treatment effect will be the difference between the each mean and the group, the grand mean. Okay. So the idea, this is the alphas. We want to see whether alphas are all zero or mu's are all the same. Okay. And to do so, before we do so, let's define the estimator, x bar as the estimator of mu, and x bar I as estimator of mu I. So that will be the notation. Okay. And we know how to find them, right? That's not something difficult. Okay. And what we want to know is, are all the mean the same, or is there any treatment effect going on? Okay. So that would be you will do the calculation as we'll show you. We haven't go through, but we'll go through in detail. Now is there will be a variance test. Okay. The main idea will be, as we have hinted last time, we are going to estimate variance in two ways. The first way is look at each group. Okay. Within each group, you calculate variance within each group. Okay. And that's an estimation based on SSW idea. Okay. And this variance, okay, will be a direct measure of the sigma square. But also you can look at this SSG. Okay. You can estimate variance based on variation of all these group means. Okay. And the idea is that if the mu1 equal to mu2 equal to mu3, this measure should not be different from this one. Okay. But if they're actually the mu1, mu2, mu3 are different, SSG will be much larger than the measure come from SSW. Okay. So it's a compare variance measure. So that's why you can do that. But anyway, let's do the decomposition first. Okay. The first is called the SST. Okay. What it states is you actually forget about the grouping. Okay. You just care about each observation and minus the overall mean, right? So just what is the notation here means you are adding each group, right, from group 1 up to group C. And for each group, you are going to add up from the first observation to the last observation. So basically what we're doing is adding every observation and minus the sample grand mean there, right? Overall. So this is how you do. If you forget about the grouping, if I ask you to calculate variance, that will be the numerator, right? The numerator of variance. If I ask you to forget about the grouping, right? Calculate the variance, and this will be the numerator. We'll get to the denominator very soon, but this is a numerator called SST. And there are two other sums that will be very useful. We'll soon show you. The first sum is called the SSG. Okay. And what you're doing is actually replacing this number by its group mean, right? So basically what you're doing is you suck down the variation within each group, right? Because each group will be represented by its group mean. So what does that mean? Suppose your data is about how much consumer to spend on each city, right? So instead, say Hong Kong, instead of having everyone's willingness to pay, you replace everyone in Hong Kong by the Hong Kong's mean. Everyone in Shenzhen will replace Shenzhen's mean, everyone in Beijing by Beijing mean. You calculate the same process. Okay, this is called SSG. The other one is called SSW. SSW is basically, you can check the formula, is replacing the grand mean by the group mean, right? So basically you're just asking, how will you actually do, right? Forget about this one, right? Forget about summation. This is how you would calculate the variance, right? If you ask the group, what's the variance in Hong Kong, right? You do the calculation, right? And what's the variance in Shanghai, so on and so forth, right? So that would be the part, okay? And would argue that the first one is equal to the adding up of the second one. So let's see why it's the case, but it's true by math, but let's see, right? So you can imagine that what's the variance is, the total variation is like you're getting from this observation to the overall grand mean here. This is in the middle of these two numbers, right? So you can, the light blue line represent how each number different from the overall grand mean, right? And also you can calculate it as from each number to the center of the data, right? And you click a square, okay? But you also can think of that from the group mean to the city set to the overall grand mean, right? So you can imagine the following, right? So you can look at from CHK to city center Hong Kong, right? How long you travel, right? From here to Central, right? This you can calculate distance, but also you can imagine we are in Satin, right? So we can go to this Satin center, and from Satin you go to MOT, right? So will be the same. Okay, so it's more or less roughly this idea, right? So you can directly go to MOT, right? But also you can take a minibus to Satin and take the highway, right, to MOT, the same, right? So you should expect this to the same, because this is dot decomposition. Okay. So once we have this, then why we want to care about that? Later we will calculate the variance based on these two measures. Okay. But before that, let me show you the calculation of SST. Okay. SST would be calculated as you calculate the overall mean, which is 4, right? 4 is coming from adding all the number, right, up and divided by 12, right? Because only 12 observation, that's give you 4. Okay. And SST will be just take each number minus 4 and square and add up, right? So you go for every single number, right? That is how you get the SST. Okay. So that is called total variation, right? So if you divide it by 12 or divide by 11, that will be sample variance, right? If you divide by 11, that will be sample variance, right? In that case. But that's the first thing. The second slide tells you the SSG, right? How are you going to SSG? SSG is, again, what you do is look at group 1. Okay. What is the mean in this one? The mean will be 2, right? It's adding up all the thing divided by 4, right? And what you're going to do is you, instead of looking at 1, 1, 2, 4, you are replacing by 2. Everything by 2, right? And by 2. Okay. And similarly, this, the mean of this is 5. Okay. The mean of this 5. So we replace this by 5. Okay. And similarly, you replace this mean is also 5. So also replace this by 5 as well. Okay. So with this new data set, right? Basically, there's no variation within each group. Okay. So only different across group. So that's why this is called SSG, right? So you basically do the same, but subtract the overall 4, right? So that's, okay. Basically, this SSG is shutting down the difference within the same group, right? So every observation is replaced as group mean. So this is a variation across group. Okay, there's nothing within group. Across different group, there's difference, but within group there's a 0, right? Because everything is replaced by the mean of its group. Okay, so this is variation across group, SSG. Okay, so that means that we decompose the variation by within group and across group, right? So that is a very natural thing to think they are adding up together. Okay, let's see. The last one is within group. Okay, so within group means that each observation, each group is minusing its own mean, right, which is 2 in this case. So that's how you get all these numbers minus 2. And for this, right, you minus 5 because 5 is the mean within this group. Same for the blue one. This is the mean of this is 5, so you minus 5 here. Okay, so I show you that these 3 are the same. Okay, so very important property that you keep in mind. This is the result there. So once you have idea of that, then we are ready to show you how we are going to do the F test. Okay, so first is there are 2 ways to decompose it, which is within and across. Okay, so the main idea you can imagine, even without thinking, is, okay, you should expect the variation within group and across groups should be roughly the same, right? If there's no grouping difference. Okay, but if there is, yes, then there's be some issue there, right? Because the same group, right? How you calculate variance should be the same, right? Because they're the same from the same stuff, right? So the SSG and SSW, based on them to calculate variance, not be the same. Should be the same, right? Because there's no grouping. The variance in each group and across group should be the same thing, right? Shouldn't be an issue. But if across group has much higher variance than within group, then we have problem. Okay. So first one will be what we call MST. It's actually something that you would do if you don't know the grouping, right? This is the one that you would, the standard sample variance, if you forget about any grouping, that would be SST. Okay, because you don't care about grouping, right? Just adding up all the observation minus the overall mean, right? That is what we call the SST. Okay, we will not use this, but this is the raw measure right? If you ever have to ask what's the variation of this data, right? That will be the MST. Okay. Instead, we'll use these two variation for purpose. Yeah. MSG, remember what it is you shut down the difference within group, but look at across group. Okay, look at group. Basically, look at the difference between the group mean and overall mean. Okay. And look at that, how many mean you got. You only have C different group, right? So that's why you divide by C minus 1 because you only have C groups, and you minus 1 because you have you fix all the C, the last one is fixed, so that's why the degree of freedom is C minus 1, okay? Because you only have C actual number, right? Because they're all the same, okay? Similarly, you can think about the idea of MSW, right? Which you are looking at mean within each group, right? So you don't care about across group. So you divide by M minus CY because you have C estimated mean, right? So that is this is the variance you calculate, right? So that is the variance, okay, within each group and variance across the grouping, right? So if there's no inherent difference between grouping, these two will be the same. Okay? But otherwise, if underlying the mean are different, this much bigger than this one. Why? Just go back to the diagram again. Okay. This variance, right, only care about the mean within each group, right? But this one will also carry the information, not just the variation of the sigma square, but also their different location, right? If they're very far away, put it this way. If these mean are very far away, MSU will be much larger than MSW, right? Can you imagine, right? They're very far apart, right? You calculate variance, right? Imagine like this, okay? Let me draw a picture to convince you, right? So look at a very extreme example, right? The mean are all very different location, right? MSW will be only care about the variation within this, right? Right? This, you calculate this gives you what? MSW. What's MSG here? MSG here is will be something like this, right? The mean may be somewhere here. I don't know, somewhere here, right? That means looking at this, this, and this, right? This blue will be MSG, okay? Across different group. So obviously, MSG will be, if that different location, MSG will be way larger than MSW, right? If they're same location, then that's okay, right? Is that clear? Remind you that because MSG is sample mean, so it can be anywhere, but in general, right, include this, right? So it can be something like more, right? But because the sample mean can be, because MSG looking at the sample mean of the group, right? So it can be, you can write it as something like more narrow down, right? Because that might be a better graph, right? It's more narrow down, but you also spread more out. Okay. So that would be the idea behind, okay? And that is the reason why, okay? So before we do that, just to tell you how to calculate that, right? So the SST is 70, right? Calculate 76 and 46. So you divide it by, this is n minus 1, right? N is 12. And this is C minus 1. C is because 3. And this is N minus C because this is, right? So you get all this number. So basically you want to compare these two number, okay? Is it 12 much larger than 5 or not, right? If 12 is large enough than 5, then you reject, okay? So there's an F test goes on here, okay? So, but let me formally define this. So you have C different group, okay? You want to say they're same mean or not, okay? So that is end up with an F test here. You compare the MSG over MSW, okay? And you check the table C minus 1 and minus C, okay? And because of this is, this will be at least as same as this one, right? You only reject if it's much larger. So this is must be a right tail test, okay? So it's not a two tail, it's a right tail because MSG will, the minimum will be just equal, right? If under the null, they're the same, okay? But only case is more than, right? You more than you reject, right? So that is the idea. So let's look at this result, okay? So you calculate this MST, MSG, MSW, right? You calculate the ratio of MSU, MSW. That gives you 2.3, right? So the idea is you have F of C minus 1, M minus C. In this case is F2, 9, okay? So this F will look like something like this, right? And of course, something 1 is here, but okay. 1 is good, right? And the problem is what we have is 2.347 here. So the question is this is 3.347 is much larger than 1 or not, right? Because 1 is something you favor the H null, right? Which is the mean are the same. So the easiest way is look at this area, right? And this area would be simply F this 2.34729 true. And remember 1 minus. You don't need to do times 2 because this is not a two tail, it's a one tail. So just only calculate the right hand side. Okay. Okay. So this is the answer. Okay. And you can check. It's going to be 15%. Okay. So it's not sufficient. Okay. So you may ask, okay, this F is so complicated, right? So would it ever actually do this calculation? No, because you do Excel or Python and immediately get all the solution. Okay. So let me show you the Excel. If there's no question, I will show you how you can get the number and then everything will be done with fairly quickly. Okay. So in the meantime, let me open Excel and prepare you to do the calculation very quickly. Let me do the open Excel file. So again, what I will do is to use the NS2 pad. So let me clear the screen first. Okay. And I will do go and NS2 pad. Okay. We have done this many times before, right? So if you don't know, you can ask the AI. I think AI can tell you this factual stuff very quickly. So what I do is I would do the data analysis, and the very first one are no for a single factor. Okay. But before I do that, let me copy the data we have, then it will be fine. It will be quickly. Will be 1, 1, 2, 4, 3, 4, 5, 8, 2459. Okay. It's group 1, group 2, group 3 here. Okay. So let me get bigger. So these are all the number data here. Okay. So if you need guidance on the Excel, so so we'll skip to a ANOVA, so we can go directly to the end of this set of slides. You can go to slide 77, 17x6, 37. Okay. So once you have that, okay, look at data analysis here, and go to the very first thing. It's called single factor ANOVA. Okay. And that is very simple. You just tell them input range. In our case, it's column A to column C. Okay. Just highlight and drag. Okay. And the data are grouped by column. So that's where we know. And because we have label in the first row, which we did, okay, if the first column have no label, then we're done, right? But we're done. Okay. And alpha, I use 5%. Okay. Now the end will be use output range, where you want to output the data, but usually I put it on the side. But you can use new spreadsheet, but I just make things easier. Okay. So that will be the answer. So you will see it tells you what's N1, N2, N3, right? And what the mean in each group and variance with each group, right? What's the sum? Okay, so that is the summary. Okay, so but what we care is ANOVA, right? So this not this first table, but rather the key point is about this second table. Okay, so you see this is right clearly SST as we said, right? And this is right SSG, right? And this is SSW, right? So we don't teach nonsense. Everything is here, right? Everything is there, right? SST, calculate directly, okay? And the degree of freedom, right? This is simply C minus 1, right? This is N minus C, and this is N minus 1, right? N is 12, right? C is 3, right? Because of 3 different groups. And what is this guy? If you still look at your slide, this is MSG, right? And this is MSW. Okay. How you get this number, right? You divide this, give you this, right? You divide this, give you this, okay? So you have the MSG, MSW. Okay. And how can you get the F, right? This F, this divided by this, give you this guy, right? This is the F, right? This is simply MSG, right, over MSW. Okay. And here you will see the critical value, right? Critical value, right? How do you get that? As we said, right? Would be just 1 minus F this 2.3478, right? This value, DF will be 2 and 9, right? So come from here, right? 2 and 9 come from there, right? And critical value, right, will be F inverse 0.9529. Okay. So maybe I should use the other color, right? Otherwise, can be confusing. So I use that color. So this is F inverse 0.9529. Okay. So this is how we know ANOVA, right? You know how to read this, right? And you look at the p-value. This p-value is 15%, right? So that means that you cannot reject the X null. So you can't say the mean are different, okay, in this case, right? And probably you need more data to reject if they're inherently different. But at the moment, it can happen, right? The alpha is 15% if you ever want to reject it, right? But the p-value is not small enough, okay? Or the F, right, is not more than the critical value, right? So you also can't reject at 5%. Is that okay? So that is ANOVA, okay? And you have seen, if you ever check my past paper, actually the last question is asking this table, okay? And we'll go over that the Monday after next week, okay? Oh, no, Wednesday after next week, sorry. Our class is Wednesday. So Wednesday after next week, we'll cover the past paper, okay? But just know how to handle this Excel output is crucial, right? Because I don't see anyone would be actually calculating by hand, right? You would be actually doing this, but you need to know how to understand the numbers, okay? How you understand the relation among them, right? I mean, in the past paper, basically, I just made a question mark on some of the number, then you have to figure out what's the rest. Okay? Is that okay? Any question? Any question before we proceed to regression? No? No? That's good. No question, then I will formally end our regression. Okay, sorry, formally end our ANOVA. We will go to the most interesting thing for class. Okay, is just remind you that we are skipping the two-way ANOVA. So when you read the slide, you just look at the thing we cover. Okay, we should forget about it. We don't have to worry about two-way ANOVA. Okay. So there's still 4 minutes before the break, so it's good time to introduce the regression, the basics, and then we'll go into detail after the break. So regression, okay? What actually regression, okay? In the previous case, ANOVA, right? It's basically simply mean one thing, right? Because we are looking at ANOVA is looking at their different grouping, the data, right? We want to see the mean are the same or not, right? And here the grouping has no meaning there, right? It's like Hong Kong, Shanghai, different city, right? But many often the grouping we have has meaning, and very often the grouping is actually coming from some numerical variable. For example, you want to study how education and income are related, right? You want to see if different education level lead to different income, right? So probably you want to say, okay, why don't I do ANOVA, right? I can have people who have high school diploma, people who have college degree, people who have master degree, right? You can do F test based on that. That's fine. Okay, then you can definitely do that. But the problem is you will notice that actually it's not that simple, right? Because you can actually find an order of this, right? People actually spend more time in college. People spend more time in education for those in college degree holder compared to high school diploma holder. Those who are having the master degree actually spend the most time in school, right? So there's a natural order. Okay, if you measure them by years in educations, then actually you want to discover how the number of years in school affect your income. Okay, and actually turn out this is actually a very famous equation called the Mincer equation, is estimate return to schooling. Okay. And actually, just people still keep doing that. And how to estimate that is still a big topic. Okay. And I think, if I remember correctly, then usually this is how much you can earn more. The return to education is usually, I think, is 6 to 8% of your lifetime salary. So if you spend one more year in school, actually you should earn 6 to 8 more percent per year. Okay, so it's a worthwhile investment. So that's why every government in everywhere, including Hong Kong, right? So give you free education up until high school, and also your education is highly subsidized, right? I think up until now, actually, your tuition is same amount as I do 20 to 30 years ago. Okay, of course, they're still increasing over the year, but it's still unchanged for a very long time. Same in NOV, you may consider different advertising channel can affect sales, and you can see whether offline, online, finding KOL, on the newspaper, which advertising channel is the best. Okay, but that is not the full story, because different channel actually cost differently, right? So you want to see, actually, instead of looking at channel, you want to see, is spending more actually help your sales, right? Rather than actual channel you're doing, right? But probably the more important question, right? So it's then the effective of your money matters. Same of drug usage, dosage, and recovery time, right? You may do an offer grouping a low dosage, high dosage, or very high, so on and so forth. But you actually want to see the actual amount, right? And that would be something we care more. So these are the problem. We want to exactly study how they're related. Okay. And regression, in the other words, is you have two numeric variable, okay? And that's you learn in topic 1, right? You have X and Y. What you want, you can have because they are all numeric, you can have a scatter plot, right? The scatter plot. Okay. And a scatter plot is the way to visualize it. And you learn from the topic 1, there are two ways to keep numerical measurement is called the covariance, right? And correlation. That's two things. Okay. But these two are just number to describe how strong they are. Okay. And once the number, that's it, right? You can't say further. What we're going to do today is do regression. And regression has two use. Okay. Okay. First, regression. What is regression first? Regression is instead of the dot with a line. Okay. And we are using a line, find a line to represent how X and Y are related. Okay. So this line actually have two purposes. First is if you know X and Y, what you know is from the data is a lot of data point, right? Okay. But it doesn't cover all the possible value of X, right? No matter how many points you get. Okay. And once you draw a line, actually you are saying that X and Y are related in infinite number of data points, right? A line is what? Infinite number of data points, right? It's all the data points. For every X, you have a Y, okay? So it's extending a knowledge from finite number of data to infinite number of possibility, right? From finite to infinite is the ideal model, right? You have a limited number of observation, but you extend the knowledge to something you have no idea, right? You have no data on that. So the first is it generalized from finite observations to infinite number of possibility. So that's the first thing. The second is it generalized in a simple way. Why? Remember, your data is as complex as the number of observations you got, right? Suppose you have 10 observations or 100 observations, is 100 number of data. But once we collapse to a line, what do we have? A line, we call your high school, can be described by two things. One, is the intercept, y-intercept, right? Later you denote as A, okay? Once I control the A and I control the slope, how steep the line is, the slope, okay? Then the line is over, right? So basically I collapse an n-dimensional data points, which is a lot of data point, to only two number, right? If I only describe y and x, I don't need the original data. I can throw away. I can keep only two number in our head, A and B, and that's it, right? Only A and B, we're done. Okay, and well, you can see actually there's actually the modern AI work, right? The LLM, right? Basically, just like billion or trillion parameter, right? To summarize what we learned, the whole civilization, right? Whole knowledge of human, right? Is boiled down to bunch of numbers, right? But that's the idea, okay? So what we do after the break is telling you that how you can draw this line. Okay? The best way. What's the best way to draw this line? How to find out A and B, and what are the good property of those. Okay. And you will see actually most of the statistics from now on you will learn is a variation of this regression, different type of regression. Here we do linear in our class. In other courses, they will do non-linear way. Okay. And here we won't have y and x. Actually, you can do more than you can y, x, z, a, b, c, d, f, g. Can be a lot. Okay. So here we're just the beginning of the long journey, if you ever start, of regression. And basically, if you do 2021, which is the subsequent course for this one, is you spend whole semester to learn regression. Okay, the whole course is about regression, nothing else. Okay, so and that's not the end, but only the first course. If you go to more, there will be more regression. If you do that department, basically, I can say at least half the course is about regression. But because regression is the most useful thing. Okay, and of course, econometrics are the same. But most of the whole building of econometrics is regression. Okay, I'm saying as I told you, AI is basically many layers of regression. Okay, but of course, the regression are very complicated type. If you ever learn the neural network, and actually many regression. Okay, so anyway, so I should stop and give you a 15 minutes break. We'll resume at 10:36. Of course, you may be waiting for the you reply, right? So let's do it. Let's resume at 10:36. So I hope you're okay. Rest assured, this is the second last time in here. Okay. Next Friday will be the last time. Look at the room around you. You will not seen this for a while. Okay. I mean, I've been teaching this at least for past 3 years. I'm teaching this class, so I know this very well. But for you guys, probably not, because I think I assigned this section for the past 3 years, so I teach the same class, same section. Of course, I think it's because of pre-assigned it for each group. So I think I often see the same people from the same concentration. But anyway, so sick, tired, and sleepy. Okay, I have an extra coffee. If anyone who need, feel free to take as my gesture. Just ask me. If you need one, raise your hand and I can give you for free. Can we find p-value without Excel? No, there's no way to do it. Okay, unless you print a very fake telephone style F table, then you can find, right? Because that's so huge. Well, do we need to know the numerator? Yeah, you know it. Because for F test, right, depend on the degree of freedom of the numerator denominator, right? In the case of ANOVA, it's C minus 1 and N minus C, right? And if you compare the standard F test, right, it's just the number of sample minus 1 for the numerator, number of sample minus 1 in the denominator, right? So it's N1 minus 1 and N2 minus 1, right? So that is that. So that is how you know, right? Because remember ANOVA, right? Just in case you forget, right? ANOVA here, right? This is 2 and 9 at the numerator denominator, right? So I hope you know it. And that means that if I ask you the p-value in the exam, if I ever ask, you just write the Excel function, right? And that's it, right? That would be thing, right? Once you write that, then you will say, if this Excel function value less than 5%, then you reject, otherwise you don't, right? So that would be something you would be asked. I mean, I try not to ask you to do a lot of calculation in the exam because it's not a computational class, right? But we need to do some minimum calculation. So some calculator will be needed, but in the worst case scenario, your calculator doesn't work or you worry, you can just write the whole expression, then we'll give you as much point as we can. Okay, we'll give points to intermediate step, right? So just try to write something, then we can give you something. If you write nothing, I cannot give anything, right? So try to write something, even if little bit off the mark, then we still give you some. We may able to give you some point out of sympathy, right? Or some effort. But if you write nothing, there's nothing we can do. Okay, try to write something if possible. What is the difference between hypothesis testing and ANOVA? Okay, hypothesis testing is, remember what I said, is you have a claim on the population. You want to look at data to see whether it's true or not. ANOVA is a special case of hypothesis testing, right? Remember at the beginning we said ANOVA is generalized two sample t-test. Two sample t-test is compare the mean of the two group, right? If to go back to here. So you ask this question. Hypothesis testing is a lot of things, right? In particular, look at the two sample test equivariance. This guy, right, is comparing the mean of the two. Okay, you see this true or not, right? You do a t-test. But if you more than two groups, you have 3 groups or 4 groups, you want to say these 3 groups have same mean or not. Okay, then we use ANOVA. So ANOVA is a special case of hypothesis testing, right? Because it's testing whether the mean of different group are same or not. Okay? Just let me draw it graphically, right? Basically, what you're saying is you have population 1, right? A bunch of men, right? That mean mu1, right? And you may have bunch of women, mu2, right? And remember, we have a bunch of elderly, maybe, right? So mu3, okay? So maybe you want to see if this mean are the same or not, right? Then you can use ANOVA, right? The ANOVA is testing the following, whether mu1 equal to mu2 equal to mu3, okay? This is ANOVA, okay? If you want to say mu1 equal to mu2, then this is two sample t-test. Or you can test mu1 equal to mu3, right? You can add other thing, right? Or you can do mu2 equal to mu3, right? So on and so forth, right? So there are many t-tests you can do, but you can do it all at once using ANOVA, okay? So that's why ANOVA is a special case of hypothesis testing, okay? You're using the variance to test it, right? Remember how we do that, right? Using the variance, right? Your idea of the F test, right? Or those F tests, but actually you are testing what? Whether they are the same mean or not. Is that clear? So let me go back to the question we have. Very good, you asked. Do you know any way to go from CU to city center like Mongkok after one? Oh, yeah, that's true. That's what I do when I was a student here. Actually, I was a student in the here for 3 years undergrad and 2 years master degree, and then at night we go to eat in Mongkok and take the minibus back, right? So there was a minibus. I think outside the Chongqing College, there's a bus in the Typo Road, and then you can go and take. But now can you do that? I think they still have that near, but not so sure these days. But yeah, I'm not entirely sure because I only take subway these days, so I don't really know. Except Uber, I guess, or taxi, but I really don't know. You can after 1 a.m. now, we still have that. Sure. Will Excel add in function? Okay. And I think if you see the past paper, you will see actually we do have that. So I don't know why you. I mean, I would not ask you how you would do the. Okay, put it this way. I would not ask you how you can put it this way. I would not ask you how you can operate the Excel add-in, right? But you would be asked, say, in this past paper, right? I do have a question like this, right? I do have a Excel output, okay? From add-in, I ask you to handle that, okay? I will not ask you how you operate the Excel add-in, right? Because that is something too simple to ask, right? Too tedious. But this type of model, this type of output, which is not just Excel, if you go to Python, same, almost the same. Use other software, R, E, views, stata to give the same table, or almost the same, or different format. So this, knowing how to handle this is very important. Okay, Excel. Okay, so this is something I'll ask. Okay, because it's not this not actually this is not Excel, right? I would say, right? This is something table that you can construct from that, but that will be the idea. When is final? Oh, why? We didn't write that down. Yeah, here. Look at the announcement. It's next Thursday. Okay, 27. Right. It's 1 hour from 7 a.m. to 7 p.m. to 8 p.m. So if you have legitimate reason to be absent, you have to apply in advance. Okay. Then we will let you know whether you allowed it. I mean, of course, you have conflicting schedule or you're sick. Okay. Then you can, we'll do a makeup. We'll let you know makeup later because we'll try to organize a makeup for all of you at the same time. But if, of course, if we can't make it one, then we'll make it individual. But we try to make a uniform makeup first. Okay. Because makeup exam will be different from the main exam, right? cannot be the same question, right? Because otherwise, if you want to take the makeup exam, will be very high mark, right? So we have to, I will maintain the same difficulty, but will be different. Okay, so don't imagine that you can take the makeup exam the same, right? I mean, you don't expect that, right? I mean, that makeup exam will be different, right? So, but I know you have some people have to go to competition. There's some many other legitimate reason. So we will give you, but you have to let me know in advance, okay? Only official valid will be accepted, right? If otherwise, we'll take you F0. Okay, have to let us know in advance. Okay, please do so. The scope of an exam, oh, everything we cover in the class. Those that I don't think there's anything we, I think everything in the slide, right? Basically everything in the slide, exclude the technical, the gray area, right? The gray boxes. And the main thing, if I would say the green boxes, if you know the green boxes, which are examples, then, and the assignments, then it should be good. Okay. So shouldn't be, will be pitched the same level as you have seen in those. Okay. It's not something too very complicated. Tomorrow's holiday, yes. I hope that you will be happy. Yeah, that's done. Everyone is Friday, yes, thank God. Best weather now? Yeah, that's okay. Regression, ANOVA, yeah, ANOVA compare average among different groups. Okay. And do note that ANOVA is compare average, but through the variance. Okay. Through the F test. Okay. So note. And we're skipping two-way ANOVA. But that's true. Actually, I also skipped two-way ANOVA last year. Okay. Because I thought that this two-way ANOVA is not all the time we use. Okay. I don't think many times we use two-way ANOVA. And it can be covered if you study more generally if you do regression. So I don't see, since you are not using it anyway, so I don't see why you have to learn this. You can actually know if you have a more general tool, you're not using it anyway. But one way ANOVA, we can still use it. But two-way ANOVA, I think very rarely people use it. I mean, if you actually need two-way ANOVA, actually run a regression. I don't see anyone actually do two-way ANOVA. Maybe I'm ignorant, but I don't really see that one. So that's why I only want to teach the thing that actually I use it, I saw it, right? So not teaching you something for the sake of exam. But that being said, if we have enough time, we cover everything, then we can come back to talk about that. But automatically exclude from the exam, okay? Even if we cover it at the end, we have time. So two-way ANOVA is gone, okay? But if I have time, I can come back to that, okay? But that would not be included in the exam. So you can safely forget about that. ANOVA, yes, that's good. The speed, okay, someone, at least two of you say, I'm too fast. Sorry about that. I already slowed down which much more compared to last year, but still, I mean, I cannot satisfy everyone. I'm sorry about that, but do let me know what's the question, and I hope to help you. And in the case you don't get it, there are two channels. One is to look at the record lecture again. Second is next Thursday, we have tutorial. Okay, so just make sure that if you have time, you can attend. The next tutorial, I think you can check, is in the next Thursday in YIA. It's in-person one, so you can bring everything. You can review the quiz and homework and question all the concept. Will be 2-hour tutorial. So you can go there, or if you have anything, you can just can't attend, you can just email. See if he can send you the Zoom link, or at least he will put the Zoom recorded tutorial online. Hopefully can satisfy. And also we will review the day before the exam, right? So the class will be just go over the past paper and do the Q&A. Okay. So hopefully that would ease your concern a little bit. Oh, we have someone with 21 of you very tired. Okay. So hopefully you're okay. Sorry, I'm dying. Yeah, I mean, I told some of you actually I'm also dying as well because I think this morning, I mean, my son is not behaving, and then my wife he just keep scolding the kid, and then my wife said, "Why are you not taking care of the kid?" And then, sorry, I'm very sleepy, and then I really don't know what's going on until she told me. Then I just take care of him, but that happened, right? Everyone's dying, especially November. So it's the worst case scenario. Don't want to have final. To be honest, your final is way much simpler than the final I took 10 years ago. My final I took is only have one A4 paper cheat sheet. Okay. And much more mathy than now. And here now you guys are very lucky already. It's open book, open notes. Yeah, everything is way more simple. Okay. And I think my exam is much longer than you guys. But anyway, but I think you guys are, I mean, of course, you compare to your group, right? So it's okay. I mean, I'm not saying that you are particularly not hardworking enough, right? Because in this generation, people are having more attraction. Okay. Attention have been scarce. So, but I mean, not to say anything, but just saying that our life is more difficult than you guys. So, so at least some uh, consolation can be said in that way. I mean, so hopefully you feel happier because we are less happy than you guys. Um, yes, I did see this news, and in fact, this is one of my research question. I did do a paper on studying uh, this game console and why they give up some exclusive rights. Okay, I do a paper on that. Okay, I'm working on that as well with a PhD student from Fudan and also his advisor. But I did know that because I do research on that as well. Um, Today's Friday. Yes, holiday tomorrow. I hope you're happy with that. And yeah, I think it's this time of day is actually not as good because usually November at this time should be very cold. Okay, but now it's hot, don't as good, right? Because when cold, you feel more concentrated, but hot is like you lose some kind of mental power. But anyway, there's no problem. Then let's continue our journey on regression. Okay. Remember, before the break, what we are going to do is the following. Just to remind you, with data x, y can be plotted in the scatter plot. The goal is to find a line with intercept A, slope B. Okay, so that's the goal. Okay, slope B, right? A intercept A. Okay, so that is the goal because once with that, the line will be y equal to A plus bx, right? So this is a formula you learn in the high school. That's called the slope intercept form, right? You know the A and the B, you have to order the line. Okay, so that would be the goal is to collapse the data into two number, and but this two number represent infinite possibility. Okay, so that is the thing. Okay, now once we have that, then now we are going to talk about what do we mean by that. Okay, let me erase it again. No, maybe make it bigger. Yes. So although we said regression, but indeed our class only focus on something we call simple linear regression. Okay, and as I said in the other course 2021, you spend the whole semester learning regression. That means that you take away the simple, you take away the linear. Okay, you learn not simple, you learn nonlinear regression. Okay. So for simple, what does that mean? Simple means you only care about two-dimensional scatter plot. It's not three-dimensional, it's not four-dimensional, it's only two. So only understand y and x. Okay. If you want more than this, then you will be not simple. Okay. So that means our data, each observation is represented by two number, X1, Y1, right? So you can imagine X1 will be education of the guy number one, and Y1 is income of guy number one, right? And Xn will be income, so education of Mr. N, and Yn will be income of Mr. N, right? So each pairs represent a single individual. Okay. And the point is, as we said already, is to build a line. Okay. When you have a line, that is the meaning of linear. Okay. That is why we have simple linear regression. Okay. And you will ask, when it's not linear? You will learn that in the next course, not my course, but maybe something like cx squared. Then that means that if you allow this to happen, that is non-linear. Okay, but in our class, we will keep our life simple. We will just care about linear, so we don't have this. Okay, but you can do more than two. You can go on and on and on. You can do many other things as well. It will be making more interesting, but we're just focusing on simple linear regression. Okay, we just saw a line. Okay, and don't underestimate this line. And this line turned out to be super powerful. Okay, it's not something that is a huge restriction, and actually there's a lot of things can be done. But anyway, let's look at terminology. We say we try to find this intercept and the slope. We will call this exercise as regress y on x. Okay, or y is regressed on x. So that is the way we describe. Okay, so that's something you know when we say we regress y on x. Okay. Once we know that, then let's start the meaning from the math. Okay. The meaning of math is ya plus bx, right? This is high school math, so hopefully make you not so tired. Okay. What's a? A is the y-intercept, right? What does that mean? Is when x equal to 0, right? What's y, right? So what the y-intercept means, right? What is the b? B means that if x increased by 1, how much y would increase, right? Increase by b. Okay. So this is something keep in your mind. We will have similar interpretation. Okay. So this is the line over here, right? So the point is the green are the data points. The question we have is to find the line to represent this data point, how x and y related. But the question would be how to find the line, right? Potentially this one line, right? And we may have another line, and someone may come up with this line. Okay. Question is, what should be the line? Because many line is possible, right? So what is the best line? Okay. The best line. So the question is, how do you find the line? Okay. Then you must come up with a criteria to evaluate, right? So just like, okay, you would say Mr. A is more handsome than Mr. B, and maybe B more handsome than Mr. C, right? That how can you judge, right? You must come up with criteria, right? How many points you give to his body shape, how much point you give his hair, right? So on and so forth. How much point you give to how muscular he is, right? So on and so forth, right? And so we have to give a criteria. The criteria we do is to look at the vertical distance. Vertical distance. Why, in particular, pick the vertical, right? For example, why we don't do horizontal, or why we don't perpendicular, right? There's many other choices. Okay. The reason we look at vertical distance is because we want to use x to explain y. Okay. There's not just y and x. It's not arbitrary. It's not, we are thinking x will be the way to help us explain y, right? Because the same as this is the income education. We want to use to see how income can be different because of education. Okay. Of course, regression don't tell you actually education changes will lead to different income, right? But at least we are trying to say, if I saw a guy who has a master degree, then I'll expect he has more income, right? But doesn't mean that if a guy who had undergrad who go to study master will have more income. Doesn't mean that, but just saying that they're correlation. Okay. So we just want you to X to explain why. So that's why it's vertical. And now first we know it's vertical. The second is what's the criteria? It's like the variance. We are minimizing the sum of all the vertical distance. Okay. So is sum of squared vertical distance. Okay. So look at this distance, you square it, add them up. Okay. You want to find a line such that the vertical distance squared, sum of them, is the smallest. Okay. And in that case, there will be only one possible line there. Okay. That's a math result, but that is the. Okay. Let me formalize this. Okay. In math. What do you mean by that? Okay. So remember your data is a bunch of green point here, right? This is the green point in the previous slide, the green point. And this line, okay? And the line, we will say y hat, right? So if you look at this again, it's a red color, right? So this is stocks, okay? Say, for example, this is x1, y1, right? This is x and y, right? And this may be x5, y5, right? The fifth data, okay? And you have a line here, okay? Well, this line will be y hat, okay, equal to a plus bx, okay? And this point will be x1, y hat 1, right? And the y hat 1 is what? Coming from the a, this is b, right? So y hat 1 will be a plus b x1, right? So this point will be x1, a plus bx1, right? So you pick this point, right? This point will be x5, y hat 5, which is equal to x5, a plus b x5, right? If we fix a and b, right? So that is the idea. And remember, you are going to minimize the vertical distance. What does that mean? It means this distance, right? So this would be d5 and this d1, right? So the distance between the point and the line, okay? Okay. And we don't want to differentiate whether it's above or below, so we square it. Doesn't really matter because we care the absolute magnitude, we square it. Okay. So that's why we care the d square. Okay, d square. We add up all the d square. Okay. The graph already in your next slide. So, but you can, if you care. So look at distance of this, right? So you are just picking A and B to minimize the distance, right? Different A means you parallel shift up and down, right? This is what the A means. You keep the same B, move up A and move up A, or keep the same A, you rotate, means you change B, right? So you keep go up and down, you rotate to find the best line. Okay? Is that clear? What you're doing, okay? Of course, this thing will be done by computer, but this is what behind this, what we call this is called the least square method, the minimum square. Okay, this square. This is called the least square method. Okay, and the story is this method actually is invented by, I think, Gauss. Okay, a famous mathematician, who tried to calculate the missing problem of the shooting star. I think actually the shooting star actually go around the Earth at that time, and people lose track for telescope. And Gauss actually used this method to calculate where it is, and actually it is that time it appear again, and that's why he get famous, and that's why this is called the least square method, if I remember correctly the story. Okay, so let's look at the diagram again, right? So basically you are looking at the line to minimize all this distance, right? You don't care about up and down, so just minimize the sum of the distance of red and blue. Okay, so that would be the idea. Okay, minimize the square distance. Okay, and just a name x, sometimes we call x explanatory variable or independent. Y is called explained it or dependent, right? It's because we use x to explain y. Okay? So here is the last few slides we talk about today. This is, last is this, okay? This least square at the very end will give you this formula, okay? And this formula seems to be amazingly complicated, okay? Of course, we can derive this from math, okay? But without doing the math, okay? Let's see what is the meaning, okay? First part is what is A here, okay? Let's rewrite this statement. U will be y bar equal to A plus bx bar. Okay, what does it mean? Pick up your high school math. You notice that this line is going to pass through x bar, y bar, right? Because this is the formula, right? So x bar, y bar solve this equation, right? So that means that the line will pass through so-called the data center, okay? The center of data, right? Because x bar, y bar. So look at the graph. Show you. So the green is the data, right? So what is x bar here? X bar is looking at the distance from the left of x, all this blue distance, okay, will be same as this all deep blue distance, right? This exactly center, right? X bar exactly located. Look at all the data. Look at all the left-hand side of x, and right side x is exactly the middle, okay? And similarly, you can do the y, okay? Y also the distance below y. Look at all the point, okay? And look at all the red here. So all the distance would be the same, okay? The sum of distance, okay? So this, the cross of this is what we call the center of data, okay? In particular, this regression will go to the center. Why is it important? Because we want to use x to explain y, right? So the first thing is, if I don't tell you an x, okay, what would be your response? What is your guess on y? Just y bar, right? If I ask you, what if you pick a random guy, I don't tell education, what you expect his income? Average income of the society, okay? If I tell you his income is, if I tell you his education is college, then your guess will be his college degree, right? So that means that if I give you the average education, you should give me the average income of the whole group, right? So that's why, because X don't tell anything, right? You want to use X to explain. If you get the data is average, you expect the average will happen. Okay? So the first thing is the model, right? is X is average, Y is average. First observation. Okay. Second observation is this formula looks amazingly crazy, right? If you see that, but if you remember, you divide by n minus 1, say, right? Or n, right? What you see, this is just covariance xy. This is variance of x. Okay, if you, or I should use S, right? Because this is a sample, so I use S. This notation we use in the class, so SXY. Okay. Or I should use a covariance XY over variance of X, right? So it means that the B is closely related to this quantity, right? And if you check if variance is 1 for X and variance of Y is also 1, then B is just correlation coefficient. If variance of X is 1, variance of Y is 1, B is just correlation coefficient. Right? But basically, B is somewhat a scaled correlation coefficient. Okay? Or scaled covariance if you want. What does that mean? It means the following. Okay? If they are positively correlated, then the B will be positive. Why? Look at the equation again. Look at B again. The denominator is sum of the squares, so must be positive. The numerator is covariance, right? So it really depends on the sign of the B is the sign of the covariance, right? If covariance is positive, B is positive, right? So this give us the graph here. See, if the covariance is positive, B is positive, right? So because the best fit line must be passing on this one, right? It cannot be negative, right? So same in the next slide. If covariance is 0, then B must be 0. Why? Because if X is useless, right? X can't tell us anything. So what is your regression model? Your model will just saying, I just use average of Y to predict, right? If income doesn't change according to education, then no matter which education I tell you, you will give me the same Y, right? So the Y hat is just same as Y bar, right? So if X is useless, then you use Y bar. So in this model, actually tell you that Y bar is our benchmark. You will later see, okay? You will always compare things by Y bar. Y bar is a model that use it without X. Okay. So the next would be similar. If your covariance is negative, then your line to be drawn will be negative slope. So there's nothing new here. Okay. The next thing to see is the denominator of the variance is, sorry, denominator B is the variance of X. So let's see. Here is if variance increase, B actually decrease. Why? Look at the red dot. Okay. The red dot have same mean, right? And you will see the red dot is closer to the center, same one. So the variance of X is smaller. But if variance of the blue dot is larger, right? Same Y, but X is different, right? So yeah, actually more flatter, right? Compare red and blue. So increase in variance will reduce the variance, reduce the B, right? The more the variance of X, right? More further away, actually the slope will be flatter. Okay. And then I should stop here because I think over time. So I will continue to talk about this. I think we should be on time, no problem. Okay. So I will see you next week. Enjoy the weekend. Have fun. I know you're tired. Have some rest. I think yesterday I have a stat class. They study how your grades The most important is how much time you study and how much sleep you have. So have enough sleep.